Welcome to my talk about SUSE maintenance and long-term service pack support. So first let's start with a quick introduction. My name is Johannes Segitz. I'm a security engineer working at SUSE. I'm based in Nuremberg office, but I'm working mostly from home, so the current situation is not a big change for me. I mainly do product and code security review. But in my former position, I worked a lot on LTSS updates, and that's the reason why I'm giving this talk. So let's dive right into it. Let's talk about SUSE Maintenance. SUSE Maintenance was born in September of 2001. Before that, Linux maintenance really did not exist. So a lot of you probably know the history of Linux, that it was a hobby project by Linus Torvalds. And in the beginning, you just couldn't get maintenance for Linux. And the original SUSE Maintenance was triggered by the needs of S390 mainframe customers. So as you can probably imagine, people that run S390 mainframes are usually people that require a lot of high quality and a lot of high reliability. And because of their need, we introduced SUSE Maintenance. So what is maintenance? It's basically everything that happens after a product or a service pack is released. So the stuff that you probably know is security updates, then classical bug fixes, and partially also feature updates. They are rather rare, but they also are part of our maintenance offering. We release them periodically, so you don't get them only like once a year, but we release them like every week. And we have a long-term service pack support offering, which I will talk about in the second part of this talk. So, why should you install updates? Do you really need them? When you talk about this, you often hear sentences like, the system has been running for ages without any problems. I don't need to install updates. Or the old saying, you better not touch a running system. There's a certain truth to that, but there are also downsides. And my personal favorite, it's not connected to the internet. So if it's not connected to the internet, you don't need to install updates. So let's cover all three of these. If a system has been running for a long time, it does not necessarily mean that it will continue like that. I have a good example for that. It's a rather old bug, but it illustrates it quite nicely. So there was a problem in the kernel that causes system freezes after 200 days of uptime. So it's a rather old issue, but still this is rather relevant. And in this case, it was fixed with a kernel update. So even if it has been running for a long time, it doesn't mean that it will continue like that. Also, I understand that people don't want to touch a system that has been running without problems, but it doesn't mean that it's in a good state. So an example for that is the file system check utility for JFS that had a problem that caused data corruption upon a power fail. So if the power failed, the server came up again. It then caused data corruption instead of fixing the file system. So your system is running, but you don't know that it's in a good state. It might be in a bad state, but you didn't have the trigger criteria that causes the problems to come up. So luckily in this instance, that didn't cause data corruption because we caught it early enough, but still you needed to install this update to not be affected. And now my personal favorite, the system is not connected to the internet. So my first question is, how sure are you that this is really true? Because maybe this was true a while ago, but a technician needed to debug something, plugged in some cable, and now it's connected to the internet. And also, how many assumptions must hold for this to actually stay true? So maybe the system right now is not connected to the internet, but maybe you reshuffle your network in 6 months, and suddenly the system is connected to the internet. And also, just because it doesn't have a modem directly connected that causes it to be directly connected to the internet, there might be ways from the internet to get to this host via various jumps. So this is kind of a dangerous assumption to make. And another question would be, how sure are you that there are no malicious actors in your network, and also that there will never be any malicious actors in your network? That probably depends on what kind of company you are, what your threat model is. But if you are a high-profile company, then this is absolutely reasonable that you might have malicious actors in your network. So even if it's not directly connected to the internet, there might be threats there. As with almost everything in life, there are certain challenges to maintenance and to releasing updates. So we want to fix bugs, but we don't want to change functionality. Because if we change functionality, then we might break something at our customer systems. Also, we sometimes need to backport fixes from upstream. So for example, the kernel or OpenSSL are rather fast moving, and we might have a product where people stay on this product for a long time with the older version of the kernel or OpenSSL, and then we need to backport changes that are necessary to fix problems from these newer versions to older versions that are not officially supported by upstream anymore. We also have certain packages that are getting fixes pretty much all the time. So Xen used to be a candidate like that. Nowadays it's slowed down quite a bit. But for a while ago, you basically got Xen fixes on a weekly basis. ImageMagick is also quite a nice example. For quite a while, we basically got 10 security issues in ImageMagick every week. So then it's difficult to decide when you actually want to release an update, because if you say, I release an update now, and then you get another report, then you need to decide, well, are they critical enough to include them? But you can't move your update forward all the time. You need to decide on a certain date when you actually want to release it. Another challenge is that we would not want to introduce regressions. So it's pretty logical that we don't want to introduce new bugs in the bug fix, but that might be something that is not as simple as it sounds, especially if the bug fix is rather complex. Another thing that's really important for our customers is that we keep the ABI, so the application binary interface, and the API, the application program interface, compatible. So if you compiled code, you first of all expect that your code still compiles on the new version that we shipped, and you also want the binary that you compiled to run with the new library, with the new version of a certain package that we released. So these need to be stay compatible to the old version. Also really important is that we include all program temporary fixes, so-called PTFs. If you come to us and ask for support, then we might give you an updated RPM that fixes your problem. These are called PTFs, and we work with you until we got the problem fixed. And then in the next update, this fix needs to be included in the update so that if you install the updated package, it actually still fixes the problem that the PTF fixed temporarily for you. An issue for us here is that from time to time we don't get feedback for PTFs, which is kind of understandable, because if you have a problem with your system, you come to us for support. We provide you a PDF, now it works. Now the motivation to provide feedback is rather low, but for us it's really important because we need to know that this is actually fixing the issue so that we can release it into the next update. Additionally, our customers run a huge variety of workloads and also various hardware setups. We try our best to recreate them in our labs, but for certain workloads or for certain hardware configuration, that is just not possible. So this is challenging when you provide updates, because then you can not test everything like it is in real life at the customer. Also, we strive to provide update descriptions from the user's point of view. So our developers from time to time are pretty geeky and pretty hardcore tech guys. So if you let them write these update texts, then normal people probably would not understand them. So we try to translate that into something that at least a skillful administrator can understand and understands why they need to install this update. So we have certain principle of updates. First of all, we want to introduce the minimal change. So the bigger the change, the bigger the risk. So we want to keep it as small as possible. We also don't want to introduce new features, unless it's a feature update, of course. But introducing new features brings additional risk, so we don't want to do that. We usually don't want to do version updates. From time to time, it's hard to avoid doing a version update, but in most cases, we really want to pinpoint the specific change and just backport that. We do regression testing, So we want to test the new package and see that nothing changed that might break working setups. And also we want to release a fix for all supported architectures. We support quite a few architectures, and we want to release the update at the same time for all architectures so that all benefit. As with almost everything in life, if there are rules, then there are certain exceptions. So sometimes the backport is just not possible. So for example, the fix itself might require a lot of code that is only available in newer versions, and introducing or backporting all of this code into the old version is riskier than just taking the new version. That needs to be evaluated on a case-by-case basis, and we have a certain process for that, where we evaluate the risk to the customer, and if we decide that a backport is riskier than just taking a version update, then we might do that in rare cases. Also, for certain products like SUSE Manager or SUSE CASP, we have different rules, because when you use SUSE Manager, you are working with SUSE Manager itself. You're not using the libraries inside SUSE Manager. So there we can change a certain library to fix a security issue because you are not a consumer of this library, you're using SUSE Manager itself. And also with packages and modules, so in SLE 12 we introduced the concept of modules. There might be different rules. So for example, the web and scripting module is moving faster than other parts of SUSE Linux Enterprise. So there might be certain exceptions, but they are documented in the modules. Of course, we do quality assurance. So every update must pass our quality assurance. And we do a combination of automatic testing with OpenQA and manual testing. OpenQA is a system to automatically run a certain amount of tests on a given system. And there are certainly other talks here in SUSECON Digital, so if you're interested, you can have a look there. OpenQA itself is a rather impressive system, and we use it extensively at SUSE. And then additionally, we also do manual tests because certain things might be easier to test manually. And in the end, we of course test the bug fix itself. That's mostly then done manually. So a tester tries to recreate the initial problem. We install the updated package, and then we check that the problem is actually fixed. So let me give you a quick visual representation of our maintenance model. As you see, the version itself is a little bit outdated, but nothing changed, so I did not change the versions. You have usually 6 months of overlap between various service packs. So if SLE 11 SP1 runs out, you have 6 months in which you can stay on SP1 and SP2 is already released, and in this time you should switch to the new service pack. So what if this doesn't work for you? What if you need more than 6 months? Then LTSS, long-term service pack support, comes in. This allows you to stay on a service pack beyond the general support, and depending on your contract, this is between 12 to 36 additional months of support that you get for a certain code stream. Currently under LTSS, you can check this on this web page. We have SUSE Linux Enterprise 15 SP0, for 12 SP1 to SP3, and for 11 SP4. So if you're running machines with these service packs, you hopefully have an LTSS subscription, because otherwise they don't get security fixes, and that makes me sad as a security guy. So quick representation here again. Basically you see the 6 months overlap here again between the various service packs, and then you can get for up to 3 years of additional support with LTSS. So that gives you a lot of additional time to decide what you want to do with a certain system. So why would you want to choose LTSS? For some of you, you might be under regulatory or legal requirement to use supported software. So basically you don't really have a choice. You might not be able to switch for a service pack for various reasons. So let's say you have software that just is only running on the service pack. Should not happen with open source software, but with closed source software that happens from time to time. So you need to stay on the service pack, but your regulatory agency tells you that you need to run a supported system, especially when you are in healthcare or in finance, this is the case, then LTSS might be an option for you. Also in cases where a system might be sunset soon and migrating just isn't worth it. So let's say you have a system, you know that in 3 months you will have a new system that replaces the current system. And in this case, you might decide that switching to the new service pack is more trouble than just going for LTSS, keeping the system for 3, 6, whatever months, and then just going to the new system. And also, I know that for certain customers, 6 months of overlap, while it's quite a bit of time, might still not be enough to migrate the environments. Some people really have really complex environments, and 6 months just might not be enough time, so then LTSS buys you more time to switch over to the new service pack. So, what is actually covered by LTSS? The thing that's really important for me to bring across here is that LTSS is not regular maintenance continued. So it's not like you just buy this contract and you get the same service that you got before. LTSS is reduced to the really important stuff. So LTSS updates are triggered by certain criteria. First criteria is remote code execution. So if an attacker can remotely attack your system and execute code, then this is obviously pretty severe, and this will trigger an LTSS update. Also, direct local privilege escalation. So let's say we have a flaw in the Linux kernel that allows an unprivileged user to gain root privileges. This is also covered by LTSS and would trigger an LTSS update. Mandatory update stick fixes. So from time to time, we need to change our update stack, and to allow you to still be able to move the system forward, you get a current update stack so that if you are on LTSS, you are then able to move the system to newer service packs. Also, issues endangering network integrity are covered. This is mostly done reactive. So if we see that customers ask for this fix, or if we decide that this is really necessary, then we will also trigger an LTSS update by that. So, and now comes something that confuses people a little bit. So the last slide showed the LTSS trigger criteria. So that means if something like that pops up, we will release an LTSS update. That is not the same, or this is not only those issues will be fixed. So at least those will be fixed by LTSS updates. It might be the case that a package is still maintained for other reasons beyond LTSS. So it might be used in a different product or whatever. And in these cases, you might get additional security fixes in the update. And with almost everything in life, this has a positive and a negative side. So the positive side is you get additional fixes beyond what is agreed upon. And the negative side is that you have a certain amount of additional risk. In my opinion, the positive side strongly outweighs the negative side, because since this package has been in use in other products, it's highly unlikely that you will run into problems that weren't seen before, and you get just more fixes for free. One good example is PHP. I had a LTSS update that was triggered for one security issue, and in the end fixed over 50 security issues because there were smaller security issues already fixed in the code, which we then shipped with the LTSS update. So let's talk about Heartbleed. A quick reminder what Heartbleed actually was. That was a really severe security issue in OpenSSL, and that was a remote information leak. So it allowed attacker via a TLS connection to read part of the memory of the target system. So this is neither remote code execution, and it's also not a local privilege escalation. It's just a security leak, information leak. But it was pretty obviously a critical security issue because it forced the complete internet to change their certificates. And in cases like these, the SUSE security team also triggers LTSS updates when we see something that is really problematic for our customers and is exploited in the wild. So this is stuff that we do in our own discretion, And that's the reason why the list that I showed you of trigger criteria is basically really only the base set of stuff that is fixed in LTSS updates. So let's talk some numbers. Let's make it a little bit more concrete. Over the last 12 months, we released around 400 LTSS updates. They contained roughly 700 packages. So sometimes you have more than one package in an update. Most of the time you just have one package, and then you have certain updates that have a lot of packages. In the following numbers, I excluded all of the Linux kernel updates. Also, I excluded the live patches because there are so many fixes in the Linux kernel that we release that would skew the numbers a lot. In these 400 LTSS updates that we released, we fixed around 1,450 issues. Of those, 666 security issues and around 800 other issues. So these other issues, they might be functionality fixes, but sometimes they are also security issues because not every security issue gets a CVE. We try hard to assign every security issue a CVE, but the system there is not perfect, so from time to time they don't get one. Some of the usual suspects are responsible for this high number. So, for example, the Firefox browser is updated regularly, and if you follow that, you know that it contains 10 to 20 security issues with every update, so that adds up over time. Then in the virtualization area, for quite a while, Xen, QEMU, libvirt brought their fair share of security issues. OpenSSL also got a lot quieter over the last months, but for a while we had quite a few OpenSSL updates. And of course, in the last 2 years, the CPU issues, so we had various microcode updates to fix all of them. So, what are the limitations of LTSS? The perfect example here is Samba badlog. Most of you will probably not know what Samba badlog is. That was a high impact vulnerability. It got this logo and it got code names, so it received quite a bit of press attention. And it basically was a man-in-the-middle attack on connections to the Samba server. And that allowed the attacker to get in the middle and then use the credentials of the user actually trying to access Samba, then do their bidding. And we backported most of the fixes to the older products. So we took them, backported them like usual and fixed it. But some of the fixes were for code that just wasn't present in these older versions. So they added code to prevent this exact security issue. And sometime later, someone noticed that this code was broken. And the really old versions did not have this code at all. So now the question is, are you affected by these issues? It kind of depends on your view. I mean, if you don't have the code that is broken, then on some level you are not affected because what's not there can't be broken. On the other hand, if the security measure that is circumvented to do this attack, it doesn't exist in the first place, then obviously you are affected. So that is kind of difficult, and in these cases it becomes really tough for us because it's usually not really doable to backport the whole functionality to old code. That is also just not something that is done in LTSS. So LTSS buys you time, but you should really use it with care and decide if it's really the right thing for your system. So when then should you really use your LTSS subscription? Don't use it without a reason. So the reason should not be, I don't want to update, let's just go for LTSS. You really need to balance your need for stability with the need for an up-to-date software. You usually have certain security functionality that you only have available in the newer versions. And while it's not always a good idea to be on the bleeding edge because sometimes you have some problems that you don't have in the older versions, having really, really old software is also problematic to a certain extent. So for your primary mail server, an LTSS subscription is probably not the perfect choice. You have quite a high attack surface there. It's probably exposed directly to the internet. you probably don't want to use LTSS for that. But if you have an internal machine and it's used by trusted employees for a specific service, then this might be a really good candidate, because then I say, okay, I have a certain amount of risk, but I can manage it, and I want to keep the system supported. So let's go with LTSS. I know that the most severe stuff will be fixed, and I know that sooner or later I will be able to go into regular maintenance again. So the important thing is that you need to consider how our LTSS offering fits your threat model. You need to know what threats you have in your organization, and then you need to check if LTSS actually covers them. That is really important. So with that, I'm through, and usually I would have question and answers here. Because of this format, I probably don't have that right now. So thank you for your attention, and see you.